What's up, y'all? Another day, another Exercism Elixir problem. Happy Friday, the 4th of January, 2019. Let's have a look at what we're doing today in Exercism. It's my favorite site for little programming practice. Today we're doing the all your base problem in the Elixir track. So I hate to repeat myself every day, but Elixir is a functional programming language that I really like. I think it's going to be the next Ruby. Maybe you're all sleeping on it. I don't know. It could be good, could be bad. Today we're going to do the all your base problem in the Elixir track. I haven't looked at this before. This live stream is going to be me solving this problem straight out. I've never read the introduction, the README. We jump over into iTerm and download it, and we'll jump over into VS Code and do the problem. All right, ready to go. VS Code, let's open the problem, and I'll pause my music so I'm out of your way. Exercism, Elixir, and all your base right at the top. Let's jump straight into the README and take a look what today's problem is all about. All your base. Convert a number represented as a sequence of digits in one base to any other base. Implement general base conversion given a number in base A, represented as a sequence of digits, convert it to base B. Note, try to implement the conversion yourself. Do not use something else to perform the conversion for you. Note, about positional notation, let's have a look. Oh, this sounds difficult. In positional notation, a number in base B can be understood as a linear combination of powers of B. All right. Yeah. Okay. The number 42 in base 10 means 4 10 to the power of 1, 2 10 to the power of 0. The number 1010 in base 2. Okay. Interesting. So yeah, binary. So we have 1 times 2 to the 5 because we've got 5 there. 0 times 2 to the 4. 1 times 2 to the 3. This is looking surprisingly similar to the stuff that we were doing yesterday in the Roman numerals one. If I jump back over to Roman numerals, we actually implemented a function that would split an integer into its parts and then multiply it by powers of 10. So that's actually quite similar. It's interesting. Let's have a look. The number 1120 in base 3 means 1 times 3 to the 3, right? This is exactly what we did yesterday. 1 times 3 to the 2, 2 times 3 to the 1, and 0 times 3 to the 0. Okay, yes, those three numbers are exactly the same. Congratulations. Really good. 42, meaning of life. All right, run the tests. Let's run those. Let's have a look. Let's make sure everything's passing. Happy days. Okay, so we haven't implemented anything. But let's go over and actually look at the tests to see what we have here. So all your base convert. So 1 to 10 is 1. 101 base 2. 10 is 5. Let's see. Let's go to the thing. Okay. Convert the digits, base A, base B. Okay, so I guess you can pass a whole bunch of digits and convert it into another base. Okay. Let me see here. Convert decimal to binary. Convert trinary to hexadecimal. Convert hexadecimal to trinary. Just going through the test just so I understand. Convert second base is 1. Base 1 we can't do. The minimum base that we need is 2. Convert first base, so negative, should also fail. Okay. So it looks like, what do we have here? Convert a 15-bit integer. Right, I see. Okay, so this one, convert decimal to binary, this is actually 42. So it's not passing in 42 because, it is passing in 42, but only because it's base 10 and we want to convert it into binary. So this is the exact same example that they gave in the README. And if we go down, I'm just going to have a look at all these cases that are invalid, right? So the second base being 0, the first base being 0, these are all nil. I wonder what happens if we convert to the same base. That seems to be totally valid. So if we start implementing our function, let's jump over. So what we want to do is probably first we want to do our general case. So let's say when the length of digits is greater than 0, because we could have a single digit, and is integer base a, and base a is greater than 1, right? Because it's got to be a minimum of 2, and is integer base b, and base b is greater than 1. So this is going to get rid of all our edge cases. So looking at that test, what I saw in the test was the fact that if we have 0, or if we have 1 as the base that we're converting, we should return nil. So all of these cases returning nil are these invalid cases. So there's a negative digit in here that should return nil. So any invalid case where, let's say, leading zeros, that's interesting. Base 7. Okay, yeah, so zeros are fine, but all these nils. So that's when we have negative numbers inside of the list of numbers. When we have invalid positive digits, so when we have a number inside the list of numbers that's greater or like equal to or greater than the power, we return nil. First base is 1. Second base is 1. So basically, we're getting rid of all of our edge cases here just to make sure that we've got correct input. What we'll do here is we'll do another convert definition here, another clause. This is overloaded. So we'll say in all other cases. In all other cases, we're just going to return nil. So that just makes sure that we have valid input that we expect. We expect the length of digits to be greater than 0. We expect base A to be an integer and greater than 1. And we expect base B to be an integer and greater than 1. And here, what we'll do is just do that. Okay, let's start implementing our function. And we'll think about what we want to do first. So I think probably what we may want to do first, if we think about an example. So let's think about an example. If we have 4, 2, and actually maybe we'll take the first test. What's the first test? Right. Okay, so the first test is binary. So we have a binary of 1, right? So we have binary of 1, and we want to convert that to decimal, which is also 1. Let's have a look at another test case that we have here, binary to decimal. So we have 101, which is 101, and that's in binary, so I should mark that in here, binary, and that should give decimal 5, right, decimal 1, and let's see here, let's go 42 in base 10, which is 4, 2 in base 10, and then we want to convert that to binary. We should have the example here. Yes. Let's just copy that in just so we have something as a reference. Okay, let's start implementing it. How would we do something like this? I'm getting a feeling that we may want to convert it to decimal and then convert it to another base. Let me just see, because basically what we need is the numbers to add to the same thing. So let's take the case of the binary 1. So that's 2 to the power of 0 and 10 to the power of 0. Yeah, I think we convert it to decimal and then convert it out to another one after. So if we take our digits and then multiply it by base A, so what we can do first is, let's just do what I always do, and we'll just send that to io.inspect. And we'll jump back over to the test. We'll grab the loading of the code, jump into IEX as always, load the code, and jump over to all your base, convert. So we have all your base, convert. And what we'll do is for our digits, we'll pass in 4 to base 10, and we want to convert it to base 2. Okay, so we just get 4, 2 out. So what you want to do here first is we'd like to multiply it out to get the decimal representation of it, because that was something that we understand. So for instance, if we pass in 4, 2 in base 10, we want to multiply it out to get 42. If we pass in 101 as a list, we want to multiply it out to get 5, and then we can convert it to another base after. I just want to convert it into something that I understand, and then we can see if there are some shortcuts to implement the base conversion. Because honestly, I don't know if there's a mathematical way to just convert bases easily, but I feel like if we have a decimal representation and we want to express it as a sum of another base, we'll be able to do that. So that to me are the two problems. One, converting our first base into decimal so we can see what it is, and the second part of the problem would be taking our decimal number and expressing it as another base, right? So we've split our problem into two sides that are somewhat easier to deal with for me personally, and that would be my approach for this particular one. So our first problem is, let's say, let's create a new little thing to express our two little problems. So we have def p, and we'll say convert to decimal. Right, so this is going to take our digits and the base, and we're going to convert it to a decimal number. We're just going to convert it to an int. Okay, and what we'll do here is we'll just pass that digits, we'll pass that over to convert to decimal, and we'll just chuck an ir.inspect at the end of that, make sure everything's still working. No, undefined function, convert to decimal. Okay, so we need 2, and this will be, we need to pass in our base A here. Load that again. Cool, nice. Let's start doing something. So what we need to do for each digit is we need to multiply it out into the base. And actually we implemented this function yesterday as part of Roman numerals. But what I'm going to do is I'm going to generalize this function, and I'm going to write it again, just so we have a look. I'm going to write it again so it's clear for you guys what's actually happening. So let me jump back over here. Actually, let me close this quickly. What we want to do here is we want to pass it into another function, and in that function we want to do an enum.map. So what we're going to do with the enum.map is go over every item in digits and multiply it by something. So the reason I'm choosing map over something else is because map is for when you're passing in a list and you want to get a list out of the exact same size doing something to each item. And so what we're going to do is pass a little function there, function digit, and we want to multiply that digit by something, right? So let's say we just did digit multiplied by 2. We can test that in our code, right? That would just do 8, 4. But actually what we want to do is we want to multiply it by the base to a particular power depending on the position in the list. So for instance, if we have 4, 2 and our base is 10, what that means is that we have 4, the thing that we want to get out is 4 to the power of 10 to the power of 1, and then 2 times 10 to the power of 0. So you can see here that we have, what is this? Why is it 1? Imagine if we had 425, that would then be 4 to the power by 10 to the power of 2, 2 by 10 to the power of 1, and then we also have 5 by 10 to the power of 0, which would just be 1. So really what we've got here is we have our base, right? And what this is the length of the list minus 1. Sorry, minus the index of where it is. And this would be the index with plus 1, right? So it'd be like a 1 index. So for instance here, this if you remember what this was base to the power of 2. The length of our list is 3, right? And the position of this, if you're looking at the list index, is 0, right? But we want to take away 1. So it'd be length minus index plus 1. And what we can do is we can just make sure that our index is adjusted by 1, so it's easier. And so what we're going to do here, because we need the index in order to determine what we're doing, we'll do enum.index, with index. And what this does is it converts our digits from something like this, 4 to 5, and it converts it into something like this where we have 4, and then the index, because we haven't passed any arguments, it's going to assume a default of 0, so it's going to be 4, 0, 2, 1, and then 5, 2, right? Because we want a 1 index, so we don't have to do this index plus 1, what we're going to do is pass a default argument of 1 here, right? So this is going to start with 1, 4, 1, 2, 2, and then 5, 3, which is what we want. And so in here, what we need to do is multiply it by something to the power. So in Elixir, we don't have a math module, but what we can do is use the math module from elixir-lang. So this is what I'm using, elixir and then math. So this is where we get the power function. So if we want to use pow, then we need math.pow, which is here. So we have that, and it returns a float. This tripped me up yesterday. So we do actually need to floor that to get it back to an integer. We don't want to be dealing with floats. We want to be dealing with integers here. So if we go back over, what we're going to do is, let's call this factor. And what this is math.pow, and it's our base. And what's our power? The power that we're putting the base to is the length of digits minus, and then here, because we've got the index now, minus index. This is what we're doing. We get our factor, which is our math.pow, and this will be base. So our base to the power of that. And then what we want to do to this is we want to floor it, and this will return an integer out of that. And so what we're going to do is multiply our digit by the factor, and then if we run this code again, we've got 40 and 2, which is exactly what we want. Let's say we do 425, this will also have the effect that we expect. 420 and 5, that's sick. So what we'll do now as well is we'll pass in 2, and this should return nil, right? This should return nil because some of the items in the list are invalid, right? So when we have base 10, the highest value that we should have in that list is 9. It should be 0 to 9. If we have anything equal to the base, it means we've got invalid input. So we're going to have a stage in this where we actually check to make sure that the input that we're getting is valid. So there's going to be a validation step. Let's implement that validation step now, just so we can get that out of the way, because that is also part of the question. And so what we'll do here is we'll do, what should we do? Do is valid digits, and then because we need base A, right? All of our bases they've already been validated, but what we need is some sort of function to validate whether or not the digits that we've got are valid. Is valid digits base. And all we need to do here is go through the digits and make sure that all of them are between 0 and our base minus 1. So for instance, if we have a base of 2, we need everything between 0 and 1, right? This is binary. So for instance, if we have 10, this is what we count in. We need 0 all the way through to 9, all right? And the way that I think we should do this is we can do it with an enum.reduce, or we can just do an enum.all. So we have our enumerable, which is digits, and what we want to do in the function is to make sure that each digit, right, each digit is between 0. So let's go 0 is less than digit, and digit is less than base. There we go. Okay, so that's going to do that. It's a nice, simple little function. And what we can do here is we can do an if statement is valid. Let's just pass that in itself. Okay, so if we have a valid input, then what we're going to do is this. Otherwise, we're going to return nil. Else, nil. And this should just work nicely. And actually, this is redundant, but we'll leave it in there to make it readable. So now if we pass in this, we should get nil out. Perfect. Okay, so now we've just implemented our validation. That's a nice, easy little step. So if we convert to decimal, this is what we're doing in here. So let's pass in some valid binary and see if it converts it to valid decimal. So let's just pass in 1. Okay, and that's 1. Let's pass in 1, 0. Right, and if we go to the next one, this should be 2. Okay, so this is, we've returned nil here, and this is wrong. And I think it's because here we need less than or equal to, because we can have digit equal to 0. Let's reload the code, get that in there. So that is 2, right? But we've returned, yes. So if we make that 1, it should be 2, 1. Perfect, easy. So we've got 3 out of there. So what we need to do now is we just need to sum up all of the items in that list. So you can see here that when we've passed in 1, 1 as binary, GoHaku88, thank you for the sub. Follow, I should say. Since we have 1, 1 and we've got it as binary, then what we want to do is sum up the values that we get out. So 1, 1 is 3. I know that because for the low numbers of binary, I'm able to do some of that in my head. You just have 2 to the power of 0, which is 1, times whatever your first value is, 2 to the power of 1, which is 2, and so on. All we need to do with that is sum it up. So if we have a list of numbers and we want to sum it up, we can simply use enum.sum. And this is just a simple way to sum up integers. So we use enum.sum. Okay. So let's reload the file. There we go. We have 3. If we pass in 4, 2 of base 10, we should get 42. If we have 4, 2, 5, we should get 425 out. Easy. Okay, so we've got our convert to decimal function done. This is very nice. So we've got our validation function, we have our convert to decimal, and that's the first part of the problem already done. The next part of the problem that we want is convert to base. And so what we have now is we have 42 or 425, and we want to convert it to our base B. And there might be a way to convert straight from base A to base B. I'm not 100% sure on what that is. It's been a while since I've done maths at a university or even a high school level. So what I'm going to do is just split it out into 2 different steps. And so this problem, we have another problem. So let's go to def p convert to base. And what we have is an integer, and we have a new base that we want to convert it to. And so let's think about how we might solve this problem. So we have, let's say we have 42, which is our example, and we want to convert it to base 2. So what we need to convert 42 into is, let's see, we had the answer in the README, base 2. So we had this 1, 0, 1, 0, 1, 0, 1, 0, 10, 10, 10. All right, 1, 0, 1, 0, 1. So let's think about the way that we might do that. So because we don't know how long the list is even going to be, we can start what we want. So probably what we want to do is we want to start building a list and do something with recursion until we've actually got the number that we want. We know that if we need to change something by 1, that first place is always going to be 1, right? Because this is always going to be something to the power of 0. And so really we know that the minimum length of the thing that we put out is either going to be 0 or 1 in that list that we put out. And so what I think we can do is try to do 42 minus 1. So let's do int minus 1, because that's really what we're trying to build out of the powers, right? No, we shouldn't necessarily do that, because what we need to do is just divide it by the power. So let's see, if we divide 42, let's see here. Let's just try and build up some powers. So convert to base, int, and then what we'll do is we'll go accumulator. So we've got another recursive function. And what we'll say is so we've got our accumulator. If let's do a cond. So if ACK is equal to this, all we're going to do is put in and int that we're trying to get is greater than 0. So let's just do all our cases first. So first we have our integer. If our integer is equal to, let's go less than 0, let's just return nil, because that's invalid. If our integer is equal to 0, we know that we're just going to return 0 there as a single element. If our integer is equal to 1, we know that we're just going to return 1 in there, because that first element is always something to the power of 0. So if we want 1, it's just that to the power of it's just 1 of that. Am I right there? Okay. And then finally, we have if integer is greater than 0, not equal to 0, and not equal to 1. And so if we've got the accumulator equal to that, we want to call our convert to base function again with the integer, the base, and what we'll have is an accumulator of 1. Is that right? Not necessarily. That's not right either. Let's just run this first. And what we'll do is we'll make this public so we can deal with it a little bit more easily. All your base dot convert to base, and we'll have, let's go 1 and a base of 10. Right, sorry. 1, base 10, and that's it. Okay, so we get 1. If we do 0, base 10, it's also there. If we do 1 in base 2, we should get 2 out. 1 out. 0 in base 2 should also be 0. So we've got those cases correct. So our other case is if we can't get it, we need to start dividing it by powers of the base. So let's just start with that first position. So really it is AC is equal to that. So let's say we have 42. We probably also want to split it out again to various things. So what do we do? So let's go base to the power of 0. Because we know that we're going to do that. And we'll pass that into elixir-lang.floor. So for instance, let's say we have 42, we have a base of 10, we have our accumulator equal to that. What we want to do is 10 to the power of 0, which is 1. And so this is our first divisor. And what are we going to do? If we do 42, we get 42 out of it as a total. We may have to start moving from the other side. Let's see here, what if we do 10? Whoops. So we get 4. So I think we probably want to go with the remainder. 0. It stumped me a little bit. If I go back to this part here, what do we have? How have we worked out that this goes into that number? I'm trying to think back. There was an example in that Magical Egypt documentary. So I think maybe what we want to do is, we know that last power is going to be 1 less than the position of it is going to be 1 less than the next one, which would be higher than the value. So we probably want to make a list, right? We want to make a list of, we want to make the list of zeros, right, where the power is less than. So what we want to get first is the first power of the base that is greater than the int that we've passed in. So how do we do that? What we'd want to do is, because we have a while loop, there's no, if we do a range, do an enum.reduce, no, that's going to be of a particular size. It's going to have to be a recursive function. So let's do another one. In here, let's just return an empty list. We need to make another function and get first. What do we want to call this? Well, we want to call this function, what the function does is it's going to return the first, the power that is larger than the number that we want. So for instance, with the power of 2, we have 2 to the power of 0, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4, 2 to the power of 5, 2 to the power of 6. Okay, 2 to the power of 6, as we can see here, is 64. And that's not right. That's going to be 2 to the 5. 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4, 2 to the 5. That's correct. So 2 to the power of 5 is 32, right? And that's the first power that's lower, the next one lower, because if we had another one in here, if we had a 0 here, and this was 1, that would be 2 to the power of 6, which is 64, and that is higher than 42. So we want to find that first power of the base that is higher than the integer that we're trying to get. First, let's call it first higher power. That's a good enough name. And then we want the integer, and we want the base. So for 42, we know that the answer is going to be 2 if we do a decimal, right? So if we have 42 and we have base 10, what we're going to return is, it's actually going to be, what will it be? The power of 2, right? That's in hundreds, because we know that the 4 is going to land in the tens column, right? Because we have, in our first column, we have 0 to 9, right, which is lower. In our next column, we have 10 to 90, right, which is the correct column. And then the next one higher, if we just do the power, so if we do 10 to the power of 2, that is 100, and that's going to be higher than 42, right, because 10 to the power of 0, let's do it like this. 10 to the power of 0 is less than 42. 10 to the power of 1 is less than 42. 10 to the power of 2 is greater than or equal to 42. And so this is what we want to do. We want to say, we'll also have an accumulator in here, which is empty. And so if, we'll do another cond. So if int, what we want is we'll do base to the power of, let's go factor is equal to math.pow base, and then we'll do the length of the accumulator. Okay. So if int, that will never be 0, that's fine. So if int is less than or equal to factor, then we just want to return the length of the ACK. Otherwise, what we want to do is want to call it again. Get first higher power. I want to do the int again, the same base, but this time in the accumulator, what we want to put in is no, we don't need that. We can just put in, this can just be 0. Then what we'll do is our, so we'll call it, what are we going to call this? Power. We can start at 0. Power plus 1. So let's run through what this is going to do. So let's say we've passed in 42, 10, and nothing, right? Which is going to make the power default to 0. Factor is going to be equal to 10 to the power of 0, right? Which is equal to 1. Then what we're doing here is if we pass in, if we say that int, this is going to be power plus 1. If we pass in an integer of 1, this is going to be true, but otherwise it's not going to be true, so we're going to pass it to the same function again, but we're going to increase the power by 1. So the next time we get it in, factor is going to be equal to 10 to the power of 1, which is equal to 10. This one is not going to be true, so we're going to pass it again. The next time we call it in, it's going to call in factor is equal to 10 to the power of 2 is equal to 100, right? And that is, int is less than or equal to the factor. And so what we actually just want to do is we just want to pass in power, right? That's exactly what we want to do. Let's reload the code and make sure that this is working. So we're going to do all your base, get first higher power, 42, 10, and this should return 2. Uh-oh. It's calling itself over and over and over again. So we'll jump out of that. I've made a serious error. This is not going as smoothly as I thought. So, okay. We need to elixir-lang.floor, and let's just inspect this to make sure that we're getting the right thing out. Inspect that. And we'll inspect that too. Let's reload the code, run that again. Okay, so we're just getting 1 each time, which means that, right, it shouldn't be 0 here. We're just doing 0 all the time. It should be power. Let's reload the code again. Load the code, first higher power. So the correct answer is 2. That is correct. And so this is working now. Let's go 42 and let's put in 2. We should have 6, right? So what we have in our example up here is that we have a list of length 6, right? So what this is giving us is the length of the list that we need in order to express our integer in that base in a list, right? So this is what that's giving us. So for instance, if we pass in 42 and 10, we know that the list that we get out is going to be too long. So it's going to be 40 and 2, right? And actually it's just going to be 4, 2 in base 10. So this function is working as we expect. I'm going to remove those comments. So get the first higher power. And actually what this is it's getting the length of the list that we need to express that integer in base power. So what we can do is, it's not a decimal point, but it's the orders of magnitude. So if we have 42 and 10, we have 4 and 2. That's fine. Let's just call it first higher power. That's totally fine. That is working as we expect. Cool. So what we have in here is we need to get something of the right length. So we have our, let's call this number list. And what we need to generate is, so we'll call this number list length is equal to get first higher power of our integer. And let's just spit that out, right? So we know what we're building up to. Spit that out. And then we'll reload the code. Get first higher power. And then we need the base as well. Cool. So it's convert to base. Let's test it with 42. Convert to base, 42, 10. Convert to base, 42, 10, right? So we're spitting out the list of length 2, right? Because all of these are false. So now what we need to do is create a list of length 2. And how are we going to do that? So I think probably what we want to do is convert a range into it. So what we can do is 1 ... and then number list length. Whoops. Okay. And if we return that, let's see that. Okay, so we have 1 ... 2, and we can convert that to a list. Let's see here. Okay, then we have 1, 2. And I wonder if there's an easier way to make a list of a particular length in Elixir. I think that doing a range might be the way to do it. The problem is that we then have values inside, and it would be nice if they were all 0 by default. So what I'm going to search for is something in enum or list. Let's jump into list first and see if there's a way to create one with a certain length, sorry. Create one with a certain length and find out if anyone in chat knows a way to create one of a certain length. That would be nice. Duplicate, just looking down here, pop at. So we've got, let's jump into enum and have a look if we've got something. I know that there's enum.into, flat into, right? I think that actually might be what we want. So what we can do is an enum.into and then we do a transform. So what we want, enum.into, and that's going to pass in the that range that we've got, and we want to turn it into a list. And the function that we get here is going to pass us each one, and we're just going to ignore it, and we're just going to return 0. And that should give us a list of all zeros, but of the correct length. Good. And if we do 425, that should give us a list of length 3 with all zeros. Perfect. Okay. That's good. So now that we have that, what we want to do is we want to go through and add up. We want to add those things up. This is really interesting. So now that we have that, let's say, for instance, we have our example, right? We have our example of 42, and 42 should bring back 4 and 2. And what it is we're adding those things up. This might be easy enough to do with a brute force, right? So for instance, what we can do here, let's divide. Yeah, I think I've got what we need to do. So what we're going to do is divide it first by the base to the power of 1. All right, so if we divide 42 by 10 to the power of 1, which is 10, right, we get 4. And we can start with that first position, and we'll see how close we get. So because this is in a functional language, we've got our accumulator here, and what we're going to do first is, when ACK is an empty list, what we're going to do is work out that to the higher power. So let's go (42), which is our int, div integer by base. All right. So let's say here we've got div integer base, and what do we have? This is the quotient, the integer quotient, int quotient is equal to div int base. Okay, and then we'll go int remainder is equal to rem int base, and then we have a bunch of cases. So if int quotient, and actually what we want to do is list dot, we want to replace, if we have our list of 0, 0, we want to convert that into 4, 0. Okay. And so let's see here. Int base accumulator. The last power. Okay. So let's update the number list anyway. Let's go. Just jump into list. I want to find out update at. There we go. So it's equal to list.update at. We have our list. We have our number list. The index that we have is going to be -2, and the function, which is going to receive the element, right, which we don't care about because it's going to be 0. And we're going to put our int quotient in there. Okay, so that's going to do 4, 0. And then what we have is if int remainder is less than the base. So in this case, right, we have the remainder of 2, and we pass it out. If the int remainder is less than base, what we want to spit out is so yeah, actually int remainder can go in that. So what happens if we do 425 by 10? The remainder is 42. Okay, that's fine. Then what we want to do is list.update, number list, -1. Oops. This is going to be our int remainder. So it's going to put that in at the last index. Otherwise, what we want to do is we want to probably call this function again with our number list. All right, I'm going to call this function again. Let's just print the what we have here. Let's just do the int remainder here. Yep. Let's do that first, just so I can get my head around this. Let's try that again. Convert to base 4210. We have 4 and 2. So that's working because that's this case, right? We have our accumulator, which has no length, and we're going to get it on the first time. The next time, if we do 425, right, we have 0, 42, and 5, which is not correct. So int remainder should not be less than base, right? That shouldn't be the case. So let me do some io.inspect in here now. Reload the code, run it again on 425. Right, so our int quotient is 42. Right, I see. So really what we want to do is we want to start with the highest power. Right, we want to start with the highest power. So highest factor is equal to math.pow base and number list length. We'll do, let's make a function just to get the power, because I'm sick of having to pipe it into erlang.abs. So we'll make our own power function. We'll have number power. All we have is math.pow, number power, and then erlang.floor. Cool. Pow base. Actually, let's call this first highest power, first higher power. And we'll do highest factor is base, first higher power minus 1. And in here, this will be first higher power, highest factor, and then we want the int quotient of that with the highest factor. And let's try that again. Cool. So we have 4, and then we have 25 left over, and this is what we need the next one for. This is what we need the next one for. So what we have is we're going to call the function again, convert to base, and this is what we're going to do here is the remainder. Int remainder, and the base is going to be the same, and the accumulator is going to be the number list. And so this function with the first highest power, let's do another case here. So we have our other case where the accumulator is not equal to the empty list. It's not equal to 1, it's not equal to 0. So in this case, we have our general case where we want, what we'll call it is the next highest factor is equal to, so we have here is number list is equal to ACK, and actually we can just do, let's call this number list, let's call it ACK, and then in here, let's change these all to ACK. So the next highest factor, what is the next highest factor? It's pow, and then it's our base, and it's not the length of our list. It's not the length of our list. We need to be passing in something else. So actually we don't want this. All right, we don't want that. The highest factor, that's fine. And actually we'll get rid of that. So if the int remainder is less than base, what we want to return is int quotient and the int remainder. Actually, this is the general case. Okay, that's fine. Otherwise, we want to convert to base again. The next highest power is the length of the ACK. All right. First higher power, let's pull that out of here. First higher power. So we got first higher power minus the length of the accumulator minus 1. All right. So what we have here in this first case is we have our highest factor. This is going to spit out, if we've got 42, it's just going to return there. Otherwise, it's going to call itself again. And the ACK here is going to be the int quotient. And we're just going to build the list over to the right. So let's have a look at what this looks like. 425, 42, right, that's good. So 425, this is calling, let's inspect our accumulator here. Oops, sorry, not there. I'm going to inspect our accumulator here. Let's load that again. Call on 425, right? So we have our accumulator, and then we have our next highest factor. Let's check that that's right. So the next highest factor is 1. No, that's, yep. That's not right. So the first higher power is 2 minus the length of the accumulator. Highest factor, that might just be that. But then the highest factor, we've already got that. Highest factor. So that would be 3. If we pass in 425, the highest factor will be 3. Let's try that again. Sorry, the highest factor, that can't be right. Why is that? Yeah. Sorry, the highest factor is 100. Highest factor is 100. First higher power minus 1. Right? 100. The int quotient is 4. The remainder is 25. Right? So the next one that we get, when it calls it again, so this is our accumulator, we've got 4. That's in the hundreds column. The next one that we get there, the next highest factor should be 10. Right? So we have that. First higher power, again, let's inspect that just to make sure that we've got... yeah, of course, because we're passing in the integer. So this extra 1, we're bringing it down by number 1 at each time. Okay, so what we'll do is we'll call inspect here, convert to base, and then we'll have, let's put in the integer here, int, and then we'll have base, and then we'll have inspect acc. Yep. Cool. And that's just going to allow us to see each iteration. So convert to base, 425, right? Next highest factor is 3. 100 is the highest factor there. We have a remainder, so we have that 4, which is the quotient, and we have a remainder of 25. The next one that we get is convert to base with 25. We have 10, 2, and then what we want to do here. So the next highest factor, again, this is what we're going to do. So we're going to do the int quotient, int remainder, int quotient, int remainder. And actually this is we're doing the same thing, right? But because we have something of a different length, if let's see here. Then all we want to do is just put in, so we have our acc list.update at acc, and the index that we want is the last one. No, that's all we're doing. So the acc is equal to acc plus, and then we have our int quotient, and then we need to check. So for instance, this is then going to put in, so we have our acc, which is 4. All right, and then we're going to add our quotient. So we're going to have 4, 2, and then our remainder 5. So we have a remainder of 5. And so what we want to do is pass it in again. So let's call, so if int remainder is equal to 0, then what we want to do is return the acc. Otherwise, we want to call it again. I want to call convert to base again. Convert to base, int remainder, base, and our new accumulator. We should be pretty close with that one, I would say. Undefined function, highest factor, next highest factor is what we want. Next highest factor, let's reload again. 425, bad argument, div 5, 0. Okay. So the next highest factor is 0. That's because, again, actually I think what we're going to do is this. It's going to be the same thing. Except in here, what we're going to do is just return the ACK. No, we're going to do ACK plus plus and then int remainder. Let's try that again. There we go, 425. So I feel like what we're doing here could be generalized, right? This could definitely be generalized here. So we've got our first one. Let's just get rid of that and see what happens. All right. Let's run it again. And it's actually still working totally fine. Again. So we got 0. Dot sum. Convert, so we got the ACK. Plus plus int quotient. Right, so we've called that with 0. And we've put it in, we've put 4 in. Why is that the case? $425. If we then 4251, right, that's what I thought. And this is because we've got the next highest factor. This should not be that. Let's see how it's called here. So we have our empty list, right? We have 10,000, which is the next highest factor. We have a remainder of 4251, convert to base, 4251. The accumulator in there is 0. We've put in 4, we've put in 251. So it's not actually adding to the accumulator. And that's because we're not passing in the ACK there. Let's try that again. 04251. Okay. That's incorrect again. So we've got 0. We have 251, 3. And again, it's because we're out by a factor of 1 here. So it's the first higher power minus the length of the accumulator. And what happens if we just make the accumulator 0 to begin with? Right. So if it's 0, then we have the next highest factor. We have a length of 1. Right. We have the int quotient, int remainder. Let's see what happens. So we still have that 4, 0, 4. It's no good. It's no good. We want the empty list. So it's first higher power minus the length of the accumulator minus 1. Let's just do that again. Try that. 4251. Okay. So the first time it's called, we have that, right? 4,000 puts in 4. The next time we get it called, this is correct. We have 251 with a base of 10, 4. The next one that we get, the next highest power is 3. Okay, then we have our accumulator. The next highest factor, right, should be 100. So it's because we've added our length of the accumulator. So the minimum length, the minimum thing that we substitute away, right, So what we have here is adjustment is equal to if ac is equal to that, then what we want is 1 else length ac. And so what this is going to do is it's always going to be a minimum of 1, right? But it's going to be 1, and then it'll be 1 again, and then it'll be 2 up from there. So we'll call that adjustment, and this should be working now. 4 to 51 and 0. Again, okay, convert to base, 51. The next highest. So really all I care about here, because we're doing too much stuff. We're printing out too much stuff. First higher power, that's not what we care about. The adjustment, we want that next highest factor. Let's run that again. So 4, 2, we're inspecting the accumulator. We don't need to do that. We already printed out at the start. Let's have a look. 4251. So convert to base 42. So we have 1000, which is correct. We have 4 of that with a remainder of 251. That's correct. So we put the 4 in to the list, and then we pass 251 to the next one. Then we have 100, which is our next one. We have 200 with 51 remainder. That's correct. Then the next one we have 51. I see. I see that the problem that's going on is that this should always be the first higher power minus 1. That's just always what it should be, because we're passing in increasingly small numbers as the in. There we go. Easy peasy. So we have our general case. So and instead of calling this next highest factor, we'll just call this highest factor. Do that again. Cool. So 4251 with a base of 10, empty list, 1000, 4, remainder 251. We put the 4 in the list, we call it again for 251. The next factor is 100. We've got 2 of those with 51 left over. We put 2 in the list. We have 51 left over. We have 10 and then 5, right, with a remainder of 1. And then we just put 5 and 1 because we know that as soon as we get to less than the base, then we can just put it in and have it finish. So if we go to 42 and 10, and let's change that to 2, and there we have a problem, right? So what we have here is we have convert to base, 2, 2, and then we have 1, 1. All right. So is that correct? And if we look back to what 42 should be in binary, it should be 1, 0, 1, 0, 1, 0. So it's 1 times 2 to the power of 5, which is 32. All right, 32 goes into 42 once with 10 left over. And here's the problem, right? So when we pass in 10, right, with a base of 2, with 1 in there already, we have 8. Right, the next power is 8. 8 goes into 10 once with 2 left over, which is wrong here because we've, instead of it being 32, this should be 16. There's a problem. Why is that not 16? I think that's probably got to do with our function here. Not the convert to base, but what did we call it? We called it get first higher power. Get first higher power, and then we had 10 and 2, right? And it is 4. But 2 to the power of 4 is 16. And so why do we have that here? Right, because we're taking 1 away. And why are we taking 1 away? Get first higher power. So no, that should be 5. So 2 to the power of 5. No. So I've made a mistake here. I've made a mistake. So really what we want, because we've got 4, which is 16. What have I done wrong here? So when we have 10, we want the next higher power, because right, if we do 4 minus 1, that's 3, and that's going to give us 8. And that's not the right place for it to be. So this should be returning 5. And why isn't it returning 5? It's finding the first higher power. The first power that's higher. But that is the case. That is the case. I think we have some logic in here that needs to be changed. And that's because if we... So we have 10 going into... We have 42 going to 32. Sorry, 32 going into 42. We have 8 going into 10. It's because we've skipped 16. We've skipped 16. We can't skip 16. We have to do something to do with the length of the list. All right? So we probably need to pass in the power that we had before. We probably have to pass in the previous power. Let's see. Should we reference the previous number? Yeah, let's just do that. We'll call that the previous power be nil. Let's make it 0. So acc list previous power is equal to acc. Okay. Acc list previous power. We don't want that first higher. We do want that first higher power, but we'll only use it here. So we have our adjustment. First higher power. What am I doing here? What am I doing? So what we have, we've got 42 over 32. And then what we get out of that is we have 1. And that's what we're passing in. So the next bunch of arguments are 10, 2, and 1. And what we want for the next one is 10 over 16. All right, 10 over 16. So it's not the first highest power. Let's have a look here. What we return will be that, and then the first highest power that we get is going to be, what is it? That is 32. No, the power will be 5, I believe. Let's just print it out. Okay. Acc list. Acc list. Otherwise, we're going to call it again, and it'll be acc list, and then first higher power. Let's see what this gives us. Good. First higher power, 42, 2. This is what we've got. So we got nil, 6, right? We got the 6 there. 32, which is 6 minus 2 to the power of 6 minus 1. 1, we made a 10. The next one that we have there is 10, right? And the next one would be 4. So what we're going to do is that first higher power, so we're going to do that conditionally based on if previous power is nil, do that. Else, what we're going to do is previous power minus 1. Okay, we'll move that iodine inspect to after here. Let's try that again. Reload the code. Undefined function, first higher power. We've changed that. First higher power will be power minus 1. And actually, what we can do is we can put the minus 1 in here for the first one, because we're only going to call it once. Power. Nice. Let's try that again. First higher power. Where are we using that again? Here. Power. Load again. Cool. Now we're working. Convert to base. There we go. So, first time we've called it, right? Power of 5. 2 to the power of 5 is 32. 32 goes into 42 once with 10 left over, right? Then we pass in, we've got our list of accumulators and the previous power that we had. So the next power, 5 minus 1 is equal to 4. 2 to the power of 4 is 16. 16 goes into 10 0 times with 10 left over. Then we'll count down again. So we put in 0 at the list. This decrements to 4, which we had in the previous one. 4 minus 1 is 3. 2 to the power of 3 is 8. 8 goes into 10 one time with 2 left over, right? Finally, we have 2, 2 to the power of 2, right? 4 goes into 2 0 times with 2 left over. Then finally, we have 2, etc. 2 to the power of 1 is 2. 2 goes into 2 once with 0 left over, so we put 1 and 0 in there. Perfect. Let's test it again with 42, 4, 2. Let's test it with 43. So that should be 1 0 1 0 1 1. Perfect. And I think this may be our general solution. 1002, 1010. See, now we have a problem. Now we have a problem. So, 1000 and base 10, we have nil. And our first highest power is 2. 100 goes into that one 10 times. That should not be allowed. It should be 3. And I think here, if we get first higher power, actually, maybe we can change that to just get highest power. Let's do that. Let's rename this function to get highest power. And instead of returning the next one up, we're going to return the highest. Okay? So if int is less than or equal to, let's reload. Let's load our code. Okay. Get highest power. 1010. So it should be 3. What if we have 42? That should be 1. Okay, so 42 should return 1 and 1000 should return 3. And the reason is power 0. So we're calling it again. Let's inspect this. And let's inspect int. Let's just do the technique of printing this out fully again. So we have get highest power. Then we have int base power. And then we have the factor. So let's print that. Cool. Let's do 1000. Okay. So finally we have 3. And see the problem here with 42, and I've made a mistake here, so let's see what happens when we do 42 and 10. Okay. And so this is another case. So we have a case when int is equal to factor, and that's when we want to return the power. If int is less than factor, we want to do power minus 1. That's not necessarily true. If int is greater than factor, we want to do the get highest power again. In all other cases, we want to do power minus 1. Let's try that. So we have 1010, that should return 3. And we have 42 and 10, and that should return 1. There we go. So we've changed that. So again, the first time we call it, we have 42, 10, and 0. The first one that we get, the factor that we get is 1, right? 42 is not equal to 1. 42 is greater than factor, so we call it again, right? The next one that we get is 42, 10, and 1, which gives us a factor of 10. 42 is not equal to 10, right? 42 is greater than 10, so we call it again. Highest power, we call it 42, 10, and 2. The factor is 100. 100 is not equal to the factor. The integer is not greater than the factor, so we want to return the power minus 1 because we've gone 1 over. So that's perfect. That's exactly what we want. And in here, what we want is that get highest power, and we just want to remove that. And so now we should be in a nice position. Get highest power, convert to base. And we have an error. So we have get highest power, 3, 1000, 1. And then again, what we need to do is we need to continue iterating, right? So we've stopped our convert to base. Why hasn't, okay, so we've got convert to base here. I'm going to remove these inspects because it's confusing me. Remove that, load the thing again. All right, so what we have here, we have 1000, we have 3 as our power, 1000 that goes into it once, we have a 0 remainder. So we have another case. So it's not just if remainder is less than base. What we want is if power is equal to 1. Right? Because we only want to do that when we have that first power. Otherwise, it's just all going to be the remainder. Let's do that again. And I've messed up. Convert to base. So we get a power of 3 that goes into 1000 goes into 1000 one time. We have 0 left over. Convert to base with 0. All right. What we want to do is cool. Let's try that. So what I've done there is, because this case is we're going to pass in 0, but every time that we get 0, we just want to put an extra 0 in the accumulator. The first time we do it, so for instance, if we pass in 0, it's going to, oh, there we go. We have a -1. And it's not ACK. It's ACK list. And we need to return power. Again, we need to make sure that we return stuff with our accumulator. So the nil, what we're going to do, that's fine. And actually we need to call convert to base again. But we need a way to check. If int is less than 0. Power is equal to 0. No, that's fine. Plus 1. Power. Convert to base 0 minus 1. That's fine. That's perfect. That's actually what we want. The power is -1. Let's see what happens if we put in 1. Right. So we've got a power of 0. Erlang plus plus. This will be ACK list. Try that again. Cool. That's what we want. Convert to base. Easy peasy. We're going to highest factor. Let's make sure that that's all working. Wait the code. So we got 0, 10, 0, 2, 1, 2, 1, 10. Should all be the same. 2, 10. Ooh. 0, 1, 2, with 0 left over. It shouldn't be power equal to 1. It should be power less than or equal to 1. Sorry, this has been very sloppy. 2, 0 again. Get highest power. Get highest power should be 0. That's right. No, again, this is right. Power is equal to 1. So we need something in the case that it's 0. So let's make a conditional in here. Power is equal to 0. Then all we want to do is return the int quotient. Power is equal to 1. We want to do, again, we want ACK list plus plus int quotient. No, again, we just want int quotient. What am I talking about? Power is equal to 1. We want to do ACK list plus 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 int quotient int remainder, and then our general case true. We want to call it again with the previous power. Happy days. Let's try that. 2, 2. Oh my gosh, what is going on here? Convert to base. Our power is 0. 2 to the 0 is 1. Right? 2 goes into... 1 goes into 2 2 times with 0 left over. Why do we have 2, 2? Why do we have 2, 2? Again, we don't want to return that. We just want to return aclist plus that. Cool. Let's do that again. Start again with 1. Cool. 0. Cool. 2. 2. 10. And so this is wrong. So what we have here with our power, our remainder, if power is equal to 0, with our ACK list, right? Our ACK list should be, see, this is the problem. Let's try that again. 2, 3, 4, nice, 14, 24, 124. Haha. 124. Convert to base. 124. 10, 2, 100. 100 goes into 124 with 1. Okay. So in here we have our ACK list. Plus plus int quotient. That's what I forgot to add. 124. Good. 3124. And let's start doing our decimal, our binaries. 4. See, that's wrong. So 3 is correct. 4 is incorrect. 4 is incorrect. So we have a first one, 4. 2 goes into 4 one time. So it's not our power. It's our previous power. So that we've got a power of 1. ACK list. Convert to base. 0. Right, of course. I think we should just get rid of these. Get rid of those cases. Reload the code. That's correct. We didn't need those cases. We could just use our general case. And really here, this could be better handled with our int. This would just be better handled with another def. All right. Convert to base. And then we have int base. And all we need to do here when, actually what we're going to do, when is integer int and int greater than 0, greater than or equal to 0, greater than or equal to 0, and what we're going to do is remove this and we'll do another clause of the function to handle the case when we have an integer that is less than 0. So all we need to do for that is we just do another convert to base, and this is only going to get called whenever we have an integer that is less than 0. So we have int base and then acc. What we need to do here is, because we're defining multiple clauses, you can't use this notation with the default arguments if you've got multiple clauses. So what we're going to do is convert to base, because what we need to do here is we need to create another clause rather than using this convenience notation. If we want to have multiple clauses, then we need to create one with 2 arguments and one with 3 arguments. So in the case that we have 2 arguments, all we want to do is just call our 3 argument convert to base. And we'll have int base and our default arguments that we pass in. And then what we'll do is we'll handle everything in the 3 argument one. So we'll do all of our error checking in the 3 argument one, int base acc. And this is our default case. So all we're going to do in our default case is just return nil. Let's just run through the different clauses. So we have our 2 argument clause. So this is the first time it gets called. The first time it gets called, it's just going to pass the int and the base, and it's going to call the 3 argument one with the default arguments. Okay, then our next clause is going to make sure that int is an integer and it's greater than or equal to 0. If that's the case, then we're going to run through our main logic, and in all other cases, we're just going to return nil. So this could be if we have something in here that results in an invalid number or something like that, calling to convert to base again, it's going to be handled and it's just going to return nil. Let's reload the code and convert to base. We'll do 3, that should be 1, 1. Let's do 5, 6, 7, and that's all still working perfectly. And so now we have the next part. So we have our convert to base of 42 to 2, and we can go back to our main function of convert, remove those comments, and then we have our convert to base. So let me save that. We'll reload the code and we'll do our convert. And we'll see what comes out. So we have our digits 4, 2, which is 42 if we have a base of 10 and we want to convert it to that. Cool. Let's convert it to 10. Should also be 4, 2. Excellent. So I think we should be passing our tests now. I'm going to start running the tests and see what we get. Cool, 21 tests, 0 failures. Now that I've run the test, I just want to check if we have any warnings coming out. We have no warnings, but I'm still printing a bunch of debug information. That's totally fine. We'll remove all those iodine inspects later once we've passed all the tests. So convert a single bit 1 to decimal, that's good. Binary to decimal, passing. Single decimal to binary, passing. Binary to multiple decimal, passing. Convert decimal to binary. So this is the one that we just did. So 4, 2 in base 10, which is 42. Going to convert that to binary. We just tested that. Passing. Trinary to hexadecimal. So this isn't something I could check with my eyes. I guess I could. Trinary. So if we have that, that's 3 to the power of 0, 3 to the power of 1, 3 to the power of 2, 3 to the power of 3. So let's have a look what that would be. 3 to the power of 1 times 2 is 6. 6 plus 9 plus 18. So 18 plus 9 is 27 plus 6 is 32. Is that right? 210. So that'll be 10 plus 16 to the power of 1, which is 32. So it's 42. They're all 42. I've messed up. So what did I have? 18 plus 9, 27. What have I done? Or is, it's 20, it's 3 to the power of 3 is 27, isn't it? Yeah, 27. 27 plus 9. 27 plus 9 is 36. Plus 6 is 42. Yeah, that's where I messed up. So they're all 42. They're all working. Cool. Hexadecimal to trinary. Nice. Let's uncomment another one. 15-bit integer. Still passing. Empty list. Passing. Single zero. We have a failure. Uh-oh. So, bad argument in arithmetic expression. Okay, so we're trying to divide by 0 here. And that is because we removed the case where, which one is it? Or your base 56, or your base 55. Okay, we're dividing that. Int is greater than or equal to 0. So it should be greater than 0. And I think we probably need to do another case where we just return 0. All right, so let's do that now. Convert to base 0, right? And then any base, it doesn't matter what base it is. If it's 0, it's always going to be the same. The accumulator, we don't care about either. It's always going to be a list of 0. And that should fix our tests. Nice. Let's uncomment the next one. Convert multiple zeros. What is this? Oh, no. That's no good. I think that's going to fail. No. What have we done? Oh, yeah, it's just returning. Where are we? Convert to base. Let me see here. Why is that? I'm actually confused why that's passing. 0, 0. It's okay. Yeah, it's because we've converted to decimal first. It's always going to convert it to 0, and then it's going to spit 0 out. That's the reason why. Crisis averted. Don't worry, chat. Okay, all tests still passing. Convert leading zeros. Again, this should pass because we're converting it to decimal first. Convert negative bit. We should return nil because we do the validation in there. Invalid positive digit. That's cool because we've done the validation. Cool. Second base is 1. Should always return nil. Cool. Convert. First base is 0. We also return nil. All of these validation ones. Let me just uncomment all of these because our validation is handling these cases. I don't need to go through them one by one. I can just do them all, and I think all our tests are going to be passing now. Excellent. So now that we've passed all the tests, it means our code is correct, and now it's time to refactor the crap out of our code, which we can then test against the tests to make sure that everything's still valid. Coming up to 2 hours, 1 hour and 50. Let's get rid of all of our io.inspect. Okay, delete that. Let's remove all of these. Inspect. Okay, so we have no inspects left. Let's run the tests again. Make sure there are no warnings. Excellent. All that's passing. And let's go through and see if there are any opportunities to refactor what we've got. So if we have our main convert function up here, we have a big check at the top to make sure that the integer is valid. So we're checking that the length of the digits is greater than 0, that base A is an integer and it's greater than 1, base B is an integer and it's also greater than 1. So this is pretty ugly. I think probably we could probably do this more clearly if we actually just do that in our validation. So what we can do is do the validation in here and make this a little bit cleaner. So what we can do is base A, base B, and base A, base B. And let's get rid of this condition because we're already doing a conditional statement. If we weren't doing a conditional statement in there, then it may not make that much sense. But since we're doing the conditional statement in there, we may as well do all the validation in here, right? Length digits is greater than 0, base A, base B. So these are all of our tests. And then we're going to just do an enum.and. We're going to do and enum.all. The digits are between 0 and the base. Okay, and maybe we can alias that all digits between 0 and base, just so we can read it in English rather than having to read the code. All digits between 0 and base. Okay, so that's doing our validation. That's cleaned up this function significantly. So all we do is validate what we've passed in, otherwise we return nil. And in here, if it is valid, we get our digits, we convert to decimal. So convert to decimal, we simply take the digits and a base, we enumerate over the digits and we multiply it out. So if we have 4, 2, right, we then turn it into 40 and then 2, and then we sum it to get 42. And so in this one, what it is it's 4 times 10 to the power of 1, 2 times 10 to the power of 0. And then we sum it all together to get 42. Perfect. I think this is a perfectly readable function. That's totally fine. The final one is that we have, so in here, here we would have 4, 2. Here we would get 42, and we pass that to convert to base. So what convert to base is getting initially, right? Initially it's getting 42 and the base of 10, right? And then it's just calling the 3 argument one. If we ever pass 0, regardless of whether we do it in recursion here or in any other case, it's always just going to return that as 0, right? Because it's down here. It's never going to call itself with 0 unless we've done it first. Actually, yep, that's fine. So this is our biggest function, convert to base. And this is doing the bulk of the heavy lifting. What that's doing is it's taking a decimal integer greater than 0. It's extracting out our default arguments. So we've got our accumulator list and the previous power, right, which will be an empty list and nil if it's the first time we've called it, right? So let's assume that what we've got is 42, 10, and we have that the first time we pass it in. Power is, so if the previous power is nil, which is what we've got, it's the get highest power. And then get highest power, what does that do? That gets the highest factor that we can of the base that we can divide into, or that is between, the int is between that factor. So what do we have here? So for instance, if we pass in 42 with a base of 10, and the first one will be a power of 0 by default, what we want is it to return 1, right? And the reason that we want to return 1 is because the highest factor for 42 is 10, which is 10 to the power of 1, right? So if we passed in 425, it would be 100, because the highest factor without going over, right? The highest factor without going over, the next highest factor would be 1000, right? But that's over. And in that case, we just want to return 100. So this is getting the highest power that will go in. And then we have our math.pow, which just is a convenient way to use integer powers. Cool. So that's pretty clear. We'll remove the comments. Let's get rid of this spacing. Format the code. I think that's pretty clean. Make sure the tests are still passing. Oops. Base does not exist. 22. less than base A. Make this base A. All digits between 0 and base A, 0 and base A. Let's do that again. And this is why you want your tests, and I think I have a warning in there as well. This clause cannot match because the previous clause at line 7 always matches. That's fine. It's because we're validating. All of our warnings are gone. Happy days. We've done it. It's nice clean code. Let's submit it. Almost at 2 hours. Exercism submit. What we want to do is all your base.exs. Very nice. Congratulations on solving the solution. Thank you very much. I'm going to mark this solution as complete. Make my solution public, and I'll share this later when I write the article up for it, explaining why. And let's have a look. In the Elixir track, we now have a tick for all your base. So what is actually my published solution? All your base solutions. Okay, I've actually been linking to this. I've been making a mistake. There we go. Okay, I've made a mistake. I need to be linking to the published solution in my articles, which are on toptechskills.com. And we're done. So if we jump back in, this is all looking good. I'm about done for today. That was a nice one. 2 hours again. These have been some marathon ones. I feel like I could probably do them quicker, but if people are enjoying it, we had some people in chat today. If everyone's enjoying it, I'll just keep doing these videos, and if I find something better, more useful, more valuable for you guys, I'll be doing that. But until next time, have fun with your Exercism Elixir. See you later.